So just to summarize at this point, we've got R, very powerful programming language. It's got a lot of its heavy lifting modules written in C, C++, and Fortran for speed and convenience. It's a scripting language that allows you to do various kinds of experimentation. Built into the core language, experimentation like data visualization, data quality, data profiling. It has built into the language very, very powerful standard statistical operations and standard plotting operations, which means that you can basically play with the data in something like RStudio, which has extensive support for working with R in that particular when you're developing some kind of R project. The other thing we want to quickly talk about is what makes R really, really powerful is this Cran network. Now, Cran is the let me go and I've got Cran up here. Cran is called the Comprehensive R Archive Network. Now, R is like a lot of modern programming language in that it allows for a public repository of specialized packages. Python follows the same model. So does Go, Rust, Ruby with Ruby gems. And the idea here is that because we're working in the data analysis community, people have already developed analytical tools for very specific kinds of data analysis. So if we go into the packages that are supplied here, if we take a look at available packages, there's a package of available packages. And we just take a quick look at the kinds of packages that are available. You'll see there's an incredible range of things from a Bayesian A/B testing, data quality visualization tool for partially accruing data. I'm even just in the A's at this particular point, spatial point patterns analysis. These are contributed generally by people who've developed them for their own projects and realize that they're useful for other people. As you can see, I'm still only in the A's and B's. There's a wide range of packages that are, for example, here's an interesting one. Was it create their block, assign, and diagnose potential interference in randomized experiments. Now that can be a little bit overwhelming, but fortunately, the packages are also organized in task views. What a task view does is it organizes the packages by categories. As you can see here, this makes it a little bit easier to work with. We've got econometrics, environmetrics, meta-analysis, missing data packages, social sciences, robust. If we go into social sciences, it gives you a list of all of the various packages that are included in this particular view. Bayesian meta-analysis, so there's a number of tasks that are associated with this. Let's go into survival, time series. We wind up with a time series analysis package, which gives you the basics of what is what's in this package, what you can do with it, and again, these are all generally very well documented. So, for example, let's take a look at WWN tests. So here's one for hypothesis test for functional time series. It has the README views. Most of these packages come with a reference manual, which describes what's in the package, how it's used, and a number of the other pieces of information regarding the package, which are going to be of use or of interest to anybody who's going to be using this package. So one of the things that makes R so powerful is this extensive repository of highly specialized packages, and you can install these packages actually quite simply. Well, in fact, we'll just do one now, just to see how simple this could be. So let's go and grab a package off of the package list, and we'll take a look at a package here. Let's take a look at, let me see, Bayesian optimization. We'll do multigraph. Now, when I install the multigraph package, it's going to go out to the Cran repository. Now, the interesting thing about installing the package, it's downloading it, but it's also now going and in some cases is actually going to compile the package down to C code that'll run very, very effectively on my system. So in this particular case, it very successfully installed the two packages, and now all of the functionality of those packages are going to be available to me in this R environment. This is, when we're talking about the power of R, this is the kind of thing that makes R really, really attractive, because I'm not always going to be reinventing the wheel. I'm always going to be able to go and leverage the work of others if it's relevant to what I'm doing. This is pretty much the standard model we find nowadays around the internet when we're working with modern programming languages, modern big data environments, is this notion of repositories, whether it's crates in Rust, packages in Go, gems in Ruby, packages in R. R was one of the first languages to really adopt this model, and it is one of the reasons why R has become very, very popular.